Hello, so I'm going to use this video to explain and talk you through how to calculate a Mann-Whitney U-test. Now don't forget there's often a lot of confusion between Mann, Whitney U and Wilcoxon because you can see by the green that they do share a lot of similarities. The main one being that they both use ordinal data. So in your exam, if you've anticipated a question on this, then you should have revised this. You've read the scenario, you've identified that the information or the level of data being used within the scenario is ordinal data. You should be thinking Mann, Whitney, Wilcoxon straight away. How you differentiate between the two is this bottom section down here. So you'll see that a Mann Whitney U uses an independent measures design, whereas a Wilcoxon uses a repeated measures design. Now, I always explain to my kids that a way to remember this is Mr. Mann, Mr. Whitney, and Mr. Wilcoxon are all doing an experiment. But Mr. Wilcoxon is cross because obviously he's got a cross in his name. He's cross and angry because he has to do both conditions, which makes him stay there all day. Whereas Mr. Mann and Mr. Whitney are dead happy because they only do one condition because they're an independent measures design, so they get to go home. So just remember Mr. Wilcoxon has got an X in his cross because he does two conditions because he's repeated measures. So once you've established it's a Mann-Whitney U-test, you must remember to use the information that's given to you within your exam. So the first couple of pages of your exam script are obviously the formulae and then the critical value tables. So once you've worked out that you need to do a Mann-Whitney U, you just find the Mann-Whitney U formulae, which looks exactly like this, and everything you see on the screen here, I'm just drawing a box around, is the information that you are given within your exam. So you'll see here we've got two formulas. It's dead straightforward this though, you've just got one for A and one for B, because obviously as we've just said it's an independent measures design, so you should have two conditions with totally separate participants. So you've got condition A or condition 1, which is UA, and then condition 2 or condition B, which we're just calling UB. It also gives you this very, very vital bit of information at the bottom here, which is that our U value, the value that we're ending with, is always the smaller one of the two that you've calculated. Now I'll explain that in a minute. So let's do one together. Now you'll be given this information, obviously, you'll be given a table of collected raw scores on your exam, but if we just use this one, so for example, I want you to imagine that within Group A I had 10 participants and say they were recalling number of words or whatever, this is whatever they've been able to recall, and then Group B here, and I've got 10 participants in Group B. Now, the first thing that I need to do is rank up all the scores as a whole group. Now this looks really confusing and I appreciate that you won't be given this table if the exam makes you to calculate this bit. Well, what I did do though is I said, right, okay, well I've got 20 participants. So if we imagine I'm ranking that data, I know then that I'm going to have a position 1, position 2, position 3, etc. all the way up to 20 positions, because if I've got 20 participants, I must have 20 positions. Imagine if you were doing a race on sports day, you've got 20 people running a race, you've got to have 20 positions. Somebody's got to be able to come 15th, 16th, 17th, etc. Now what I did then is I took the raw scores out of the table. Now I did this for Group A and for Group B, so I mixed in, just for this, I mixed in both Group A and Group B's raw scores. And I literally put them in order from smallest to largest, so you'll see. And if you're not sure, I'll put the table back on the screen in a second, or by all means rewind and check. But you will see that the smallest score that I presented there was 5, and the largest score that was presented was 18. So I just put those numbers in order. You'll also see I've got some repeat numbers, and that's fine as well. This is the slightly challenging bit within this one, and this is the bit where the most mistakes are made, so we have to be nice and careful here. Is what I then do is I rank the score. So for example, I say, right, okay, well if somebody's run a race on sports day in 5 seconds, they're obviously quicker than everybody else, so they win. So they're rank 1. And then again, the second person has got 6 seconds, so they must have come second, so they're rank 2. Where it gets slightly confusing, or where you need to be careful, and I'll just draw so you can see where I'm looking at, is here. Because what you'll see here is I had 2 people run that race within 7 seconds, for example. So person number 3 and person number 4 ran it within 7 seconds. Now we all know in sports day, if you literally tie with the exact same time as somebody else, you would go mental, wouldn't you? You'd be furious if they got 3rd place and got a bronze medal and you got 4th place and didn't get any medal at all, even though you both ran the race in the same time. So we can't just say, right, well you come 3rd then and you come 4th. So what we have to do in the art of fairness is their rank has to be shared and it has to be equal. So what I've done in this situation is I've said, right, okay, well they need to share rank 3 and position 3 and position 4. So if I add position 3 and position 4 together, I get 7. There are 2 that I'm sharing it between, so I divide it by 2. So in which case, obviously half of 7 is 3.5. So I'm going to give those both the rank of 3.5. I'm going to do another one just so you can see what I'm doing again here, because I appreciate the fact that the 7 repeated wasn't very helpful there. So let's do this one here, the 9s. Okay, so again, I've got another situation where the 8th and the 9th person to cross that finish line both ran the race within 9 seconds. So they got exactly the same score. So it isn't fair of me to say, well, you come 8th and you come 9th, because that would obviously cause uproar. So what I do is I say, right, well, they're fighting over position 8 and 9. So if I add 8 and 9 together, I get 17. If I half those positions to make this fair, then obviously I get 8.5. So I'm going to give this person rank 8.5 and this person rank 8.5. By all means, if you are struggling with this, pause the video on this screen and have a little bit more of a practice, because you can see here, we've obviously got same numbers here for 13, we've got 2 16s here, 2 17s here, 3 11s here. Now on that 11 one, I just split it 3 ways. So I would say, right, well, 3 people ran the race in 11 seconds. So I do 10 plus 11 plus 12, because they're obviously fighting over position 10, 11 and 12. So that would give me 33. But this time I've got 3 people who got the same score. So I'm going to share that 33 between 3 people, and therefore everybody gets rank 11. So just spend a little bit more time on this slide if you need to. Honestly now, I will be very surprised if they make you do this on your exam. To me, I think that they're more likely to give you the raw score and the ranks within them and then see if you can apply the formula. I don't know that. Obviously, I don't know that. But I would be very shocked if they made you do this. Now, I think we should prepare just in case, but I will be very shocked. Now, what I've done then is I've literally just put the information or the ranks that I've just assigned on that last table. I've just put those ranks back into my table. So, for example, if we find number 5, we know that whoever ran that race in 5 seconds, we said was the quickest, so they won. And you can see here that I've therefore just put a 1 in their rank column. Okay, so whatever rank I just assigned them, I've just put back into the column. And again, I've split A and B back again and just put the ranks across. Now, what we have to do is we have to find the sum of the ranks. Now remember, the word sum in maths means total. So down here, I've just done the sum of the ranks, which means I've added all of these numbers together down here to get 75.5. And I've added all of these numbers together here to get 134.5. Now don't forget, instead of saying sum, it might just give us this sign that I've just drawn on the board there, which is called sigma, which just means sum. Now, once I've done that, I've got the sum of ranks. And if you see here, this is the bit of each formula that I've just worked out, because I've done, there's that sigma sign we just talked about. So I've done sigma, or sum of, the ranks of A. And down here, I then did the sum of the ranks of B. So I've done that bit in the green of each formula. What I'm going to do now is use the formula. So for example, let's have a quick focus on here of UA. Now remember, UA just means condition A. So it just means I'm only going to use the data on this UA for the condition A, or the raw scores that I use there. Now, top tip on this is to remember that N within psychology just means number of participants. We're not particularly inventive. So here, for example, if I want to find out the Mann Whitney U score for group A, I'm going to do the number of participants of A, so the number of participants of A times by the number of participants of B, plus the number of participants of A times by the number of participants of A plus 1, divided by 2 and minus the sum of the ranks. Now I appreciate that sounds really scary, but I promise it isn't. Let's work through it. So here, for example, I'm on group A. So as I've just said, I'm going to do the number of participants of A times the number of participants of B plus the number of participants A times by the number of participants of A plus 1 divided by 2 divided by the sum of the ranks. So let's put some numbers in. Now I know that in condition A, I had 10 participants, and in condition B, I had 10 participants. So I've just got a lot of 10s going on. So I'm doing 10 times 10 plus 10 times whatever 10 plus 1 is, which is obviously 11, divided by 2. And then you'll see here that instead of writing the ranks of A, I've put my 75.5 in, because that was my sum of the table. So let's actually work this out a little bit here. So 10 times 10 is obviously 100. 10 times what would be 11, because remember we do the brackets first in maths, so we would do 10 plus 1, which is 11. So 10 times 11 is 110. So I've got 100 plus 110. And then I work that out first and then divide it by 2. And then the last thing I'm going to do is take away my sum of the ranks. So if I do 100 plus 110, I've obviously got 210. If I divide that by 2 and then take away my 75.5, I will get 79.5 as my final U value. Now don't forget though, that's just for condition A. So here, I'm going to do exactly the same, but just for list B. So again, I'm going to take my UB formula this time, which you will notice is exactly the same as UA, but they're just, obviously, if we've got different number of participants in condition 1 and condition 2, then it's particularly important. But here, for example, so I'm going to do UB again, number of participants in A times the number of participants in B plus the number of participants in B times by the number of participants in B plus 1 divided by 2 minus that sum of the ranks B, which we worked out on the previous table. Again, let's just put some numbers in, work it out, then you will see actually my UB score is 20.5. Now remember I pointed out this very important piece of information to you at the beginning, which it does give you on the exam, so it's there for everybody to see, which is our final U value is therefore the smaller of those. And I tell you what they'll do on an exam is they'll give you a little answer box at the bottom that says U equals, and your final mark will be for choosing the two numbers that you've just worked out and putting your final one there. Now obviously our two numbers are 79.5 and then 20.5, so our smallest value is obviously 20.5, so that's going to be our final U value. Unfortunately, we're not quite done because, well, we are done in terms of calculating our U value, but what they often then do is then give you another question where they ask you about the significance of the results then. And this is where our critical value table comes in as really, really important. Now, remember I said that they give you these at the beginning of your exam. They're the first couple of pages. Unfortunately for Mann Whitney, you get 4, but I'll explain that in a minute. But they're really, really easy to use. So here, if you remember, we had 10 participants in each condition. So where it says N, remember I said that N always stands for number of participants. So because the number of participants in A was 10, I'm going to go across to 10. And then down here, you will see as well that I'm using this one. I'm using the value of P is less than 0.05 for a one-tailed hypothesis. So I'm basically working out that the probability of my results being down to chance is less than 5%. So I'm 95% sure that I can say that there was an effect from the IV onto the DV. So I'm going to go down here for my number of participants in A, was 10, number of participants in B was 10. So if I go across 10, 10, then I get this number down here, which is called my critical value. So my critical value, therefore, in this case is going to be 27. Now, this is the rule that you need to remember, but it's really, really easy. If there is an R in the name of the statistical test that you're being asked to work out, then you want your calculated value, the value that you have calculated, to be greater or equal to the critical value. If there is no R, because obviously there's an R there, if there's no R in the test that you're being asked to calculate, then you want your calculated value, the value that you worked out, to be less than or equal to the critical value. So is there an R in Mann Whitney, in the word Mann Whitney? Is there an R? No, obviously not. So in this case, we need our calculated value, the value that we worked out, to be less than the critical table. Well, is it? Well, our U value was 20.5 and our critical value was 27. And look how I am using those words in my write-up. So I'm saying the U value of 20.5 is less than the critical value for a one-tailed test, because I showed you that on the critical value table. Therefore, our results are significant at the level of P is less than 0.05. My top tip here, don't forget though, is often if they've given you an AO2 scenario and asked you to deem whether the results are significant or not, your third mark is often AO2. So you've got to then go back and say, therefore showing that I don't know, amount of energy drink that you drink does affect what space you come on sports day or what position you come on sports day or whatever the scenario is, but you've just got to go back and put the IV and DV back into your results. Now I mentioned this very briefly, but there are 4 critical value tables for a Mann Whitney. So if you are asked to calculate a Mann Whitney, the difficulty then is deciding of which critical value to use. But it's dead straightforward. You just need to decide whether your hypothesis is one or two-tailed, and they will tell you that on the exam. They will get you to write either a one or a two-tailed hypothesis. And once you've decided that then will help you to work out. It will also tell you what level of significance. So for example, it will say, you've written a one-tailed hypothesis, for example, and it will ask you, are the results significant at the level of 0.05? In which case you flick through your paper and you say, right, okay, I need a one-tailed hypothesis at 0.05, and therefore you know that that is the number that you are referring to. That's the critical value table that you're looking at. Hope that helps.